Everybody, thank you for attending this webinar. I'm Nicholas Derico. I'm a cloud solutions architect at Oracle, specialized in the MySQL database, and especially for today, the MySQL database service. I'm based in the San Francisco Bay Area, and so if people are joining from the San Francisco Bay area, it's possible we have met before. So welcome even more. And yeah, so the topic for today is how to migrate, kind of like how, but also why to migrate from Aurora MySQL to the MySQL database service in Oracle Cloud. So to begin with, I'm just going to make a quick introduction to the MySQL database service that we have now in the Oracle Cloud, and a little bit of differentiation between that service and the Aurora MySQL service, both in terms of functionality, but also of cost. And then continuing the introduction, I'll mention some of the options that we have for high availability that are native to this solution, as well as high performance options, and showing a few benchmarks, at the same time. And then after that, we'll go on to the kind of a step-by-step migration process, going from the Aurora MySQL to the MySQL database service in Oracle Cloud. So first off, just want to talk about the MySQL database service, what it is. So this is became available for public to use in September 2020, and since then it's been becoming widely adopted. So it's very good service. Uh, where it's very different from, let's say, other clouds and other forks, of MySQL, is that it is the MySQL. It's like the original, the native MySQL, with developed by the MySQL engineers. You may meet them sometimes at conferences and so on. So these are the same people who develop both the on-premise, the open source, and the MySQL database service. And the reason why they develop both is that it's not both, it's like one. It's one. The MySQL database service is MySQL 8. It's the same software. It's just that we deliver as a service, and we deliver as open source, and we deliver. There's also a commercial edition called MySQL Enterprise Edition, which is the kind of like the open source version, but in addition has additional security functionality, privacy features, for the enterprise. And so the MySQL database service is basically the MySQL Enterprise Edition, but made available by the MySQL team and managed and supported by the MySQL team in the Oracle Cloud. Being that it is MySQL, and specifically it is the latest always, MySQL 8. And if we compare with Aurora, so Aurora is basically kind of a copy of MySQL, but it's kind of like a fork of MySQL 5.6 with added features coming from 5.7. So with Aurora, when you make an instance, like an Aurora cluster, you choose, is that going to be Aurora 5.6 or 5.7? But the MySQL database service is MySQL 8. And so because of that, there are some features that are in MySQL 8, in MySQL database service, that don't exist in Aurora. And this is maybe one of the reasons why somebody would migrate from Aurora to the MySQL database service. So just going down the list quickly, MySQL 8, MySQL database service has roles, account roles, so the role is, there's a command called create role, and then you can grant privileges to the roles, and then you can assign the roles to users, you can assign roles to roles, you can assign multiple roles to multiple users, So what happens is that we implemented it similar to roles in the Oracle database, with like the hierarchy of privileges and roles. And it's kind of like a nice way to centralize the management of the database privileges for the users. So going down the list a little bit more, so there's a lot of the development in MySQL 8 is on the SQL functionality. So we have, for example, hash joins. which were not there before. So, Aurora probably doesn't have hash joins, lateral derived tables, common table expressions, window functions, and then check constraints. So we also developed the JSON capabilities of MySQL. So you can put a template in MySQL database to say, okay, I just want to have that's like JSON is kind of schemaless, but sometimes people want a minimum schema. They want a few things. Like if it's an email, you may want the email, the to field, the from field. So you can have a validation that some fields are present, as well as multi-value indexes for JSON arrays. So this is kind of a just a sample of functionality in MySQL database service that could attract users of Aura to migrate to Oracle Cloud. And there's way more. Continuing actually along those lines, is one of the nice features of MySQL 8 is the ability to use MySQL as a document store for JSON documents. So imagine if you combine the MySQL technology a little bit with like Mongo technology, as one centralized database. So in like one database. So this is kind of like what the MySQL document store is. And but this is in MySQL 8. Okay, so MySQL database service has that functionality where we provide the SQL, regular SQL functions with JSON documents, so you can load JSON documents in MySQL, but we also provide NoSQL connectors that, for like JavaScript and C++, C Sharp, Python, and several other ones, where somebody could write SQL or NoSQL programs, and these will basically run natively against the MySQL database service. And the JSON documents, which are used by the NoSQL side of MySQL, are the same as the ones that are available for the SQL side. So you can basically access the same documents both ways with NoSQL applications and SQL applications. So this is available again in the Oracle Cloud in the MySQL database service. And somebody that wants to make use of this technique, then then they would have to come to the Oracle Cloud and migrate, to the Oracle Cloud. Um, so I mentioned that it's the same. The MySQL database service is MySQL 8, and what that means really is that if you download the MySQL Community Edition, which is like the open source, or if you download the Enterprise Edition for your on-premise deployments, then the MySQL database service is the same thing. It's the same software. And so you can make a hybrid deployment very simply with MySQL, knowing that your application will run the same on-premise or the same in Oracle Cloud. And MySQL being an open source technology, I am thankful that people make forks, of MySQL. So it's kind of a ubiquitous database in all of the clouds. You could even run MySQL Enterprise Edition, for example, in AWS EC2 nodes. People do that. And so, it's kind of like a one database for all deployments. It's just that the one in Oracle Cloud is, in my opinion, is the best. It's the one by the MySQL team. And also it is supported by the MySQL team. So if you open a support ticket with Oracle, the MySQL database service, it goes to the MySQL team. And the MySQL support and the MySQL engineering, they're part, the same organization. So there's very strong links. And, we can, in my opinion, the MySQL support is like the top experts, on the planet for MySQL. So this is where your support tickets go. I think in contrast, other cloud providers, they may not have, very strong support for MySQL. The support will be for the, let's say the tooling, like the backup and if the instance is doing failovers, things like that. But I think if you have a feature request or if you need help on optimizing queries, I believe, of course, like, the real MySQL experts will will do that. There's also another reason, I haven't really mentioned yet, to use the Oracle Cloud for MySQL database, and that is the cost. And even though we are the ones to develop the MySQL database service, You will see in a few moments, there's a pretty dramatic cost difference between the MySQL database service and the other ones. And I don't even know why, but that it is the case. I don't know why the other ones are so expensive, but it is the case that the MySQL database service is a huge difference in cost. And but before going to the cost, just want to mention also that the MySQL database, just in general, being open source and also being available in the like everywhere basically, is makes it a very popular database. And this is a survey, in 2020, of popularity of databases, and you can see that MySQL is remains the #1 popular database. Not even just open source, open source even more, but just in general, because there's a SQL Server, Microsoft SQL Server is closed source, of course. So it makes sense to develop for MySQL just in general, because you can run your applications anywhere, knowing that MySQL is supported everywhere. But again, like the one in Oracle Cloud is, in my opinion, the best one. Okay, so going to the costs. So this is as much as we could do apples to apples comparison. We went to the other clouds and to Oracle Cloud, just the regular published price list. We plugged in the numbers, 100 CPUs. Oracle Cloud OCPU means two is like one core, so it means one core has two execution threads. So that's like two vCPUs in Amazon. So we went in the other clouds. We plugged in the numbers of equivalent to 100 OCPUs, 1 terabyte of database storage. And so these are the numbers that we came out with. Just be aware that in Oracle Cloud, the MySQL database service has one core brings 16 gigabytes of RAM. So let's say for Azure, to make kind of apples to apples, we chose the memory optimized version, of their service. And for Amazon is like the R5, the R5, equivalent, and so on. Okay, so Google also is kind of like a high memory optimized, just to get to approximately 16 gigabytes, just to be as close to as accurate as we could in the numbers. And we chose the US East kind of region, because that's where everybody has some data centers. What's interesting is that in the case of Oracle Cloud, unlike the other clouds, it's the same price in all of the regions. Okay, so you don't need to be like, oh, I want to save money, I'm going to go to like the far away region. You can, it's always the same price, and it's always the lowest price. So it's very simple. Okay, so when you create the MySQL database service, the first thing you're presented with is this window that asks, okay, what kind of database service you want. So the standalone is basically the stock MySQL database service. And then there's a high availability option that you could choose that is going to be like, with like minimum downtime, like near zero downtime, and basically zero, recovery point. So, and there's also a high performance that was announced, I think in December 2020, called the Heatwave, which is a high performance option that goes with MySQL that accelerates queries in a very dramatic fashion. So going to the high availability, this is what how we implement high availability in Oracle Cloud. And just be aware that, even if you have one standalone, even if you have like the standalone one MySQL server, there is high availability as well, because of course, if there's a problem, then we restart, we restart the instance on another compute node. So there is like high availability built in anyway. But in this case, what I'm talking about is a much higher high availability, where we use the technology called group replication that we have on on premise, but also we have it in the Oracle Cloud. And group replication is a technology where there are 3 or more MySQL servers that interact and work together as a group. And then what happens is that they're all aware of each other's status. And if they know if one is up, they know if one is down. And if there's a failure of one of the servers, then the remaining ones elect a new server to be the primary. So the primary server is the server that receives all the writes in the queries, and then it pushes synchronously the writes to the other servers. And so the servers are always synchronized. Um, and so if the primary is suddenly not available, then another one becomes the primary. And this is done with nothing on the application. Okay, the application is completely unaware of this. And on premise, we have something called MySQL InnoDB cluster, which is kind of a framework above group replication that connects the applications to the cluster of MySQL servers. So yeah, MySQL InnoDB cluster is kind of the on-premise framework. And for connectivity, whereas in Oracle Cloud, the framework is called Oracle Cloud. We basically use Oracle Cloud functionality where we provide a single IP address, and that IP address basically points always to the current primary. So the application, they don't need to be reconfigured if there's a failover. The IP address just follows which is the current primary. For the highest level of high availability, a lot of the Oracle Cloud regions have three what we call availability domains. So these are, let's say, one or more data centers that work, as an availability domain. And so we spread out the MySQL servers across the availability domains, just to make sure that if it were to happen that a complete availability domain is down, then that's okay, because there's two more to go. There's two more for your applications and for the MySQL servers to reside on. And the failover is transparent. Okay, so there's nothing to do here. There's nothing to configure even. This is like the default how it works. And Oracle Cloud is expanding very quickly. So like, maybe a dozen regions a year these days. So some of the new regions have only one availability domain, but even with that, within each availability domain, we have kind of sub-regions called fault domains, which are physical separations of like regions within the availability domain that ensure that there's no physical dependencies between the hardware. And so even if there's a region with one availability domain, within that availability domain, the MySQL servers are going to be split across. They're going to be spread across the fault domains to remove any sort of physical dependencies between them. So yeah, so this is like a great high availability solution, and it's very easy to manage. It's managed by clicking, this checkbox, and that's it. That's all you have to do, and then you get that. And for the Heatwave high performance option, the way that this works is you have the MySQL database service that englobes all this, and so you have the MySQL database, which is like the front end. It receives the queries, it stores the data in InnoDB, just the same as like all of the other MySQL, the regular stock MySQL database service. But in addition to that, we create a cluster of high performance nodes, Heatwave nodes that have a subset of the data, and these are optimized for running, let's say, like analytics kind of workloads. And so the subset of data is always synchronized with what's in the MySQL database. So if you make a insert, for example, then the insert is immediately reflected in the Heatwave nodes. And so when a query comes to the MySQL database, the MySQL will take a look at it and determine, okay, is it faster to run it against InnoDB? Which sometimes it is, the role-based kind of queries can be faster in InnoDB, but often, almost all the time, it's faster to run in the Heatwave because it's really optimized. It also has, it's fast for both row-based and columnar-based queries. It does both. So most of the time, it's faster in the Heatwave. So it's a transparent mechanism that it will run the queries locally or in Heatwave, and you get a very fast, very fast performance increase just by using the Heatwave option, which is again, just a checkbox. You say, okay, I want Heatwave, or you don't want Heatwave. Looking at the performance differences with the stock MySQL, we ran the TPCH suite. It has I think it's 22 queries if I remember correctly. So we run the queries. It's kind of a TPCH, if you're not familiar, is kind of like a benchmark suite that that analytical databases can use to compare with each other. So you can say, okay, this is how fast this database is with analytical queries. This is how fast this one is, and you can make some comparisons. And so we use that and to make a comparison between the stock MySQL database service and Heatwave, and look at this. And by the way, we on the stock MySQL, we use indexes, so it's optimized. It's the best we could do. We don't try to be cheap and like make it an optimized configuration versus a Heatwave. So it's like optimized MySQL with indexes with Heatwave, and a Heatwave on average is 400 times faster. But what does that mean? Let's compare with another real life scenario. So looking at we compare with Redshift. They may run analytic workloads in Redshift. So let's run TPCH in Redshift versus TPCH in MySQL versus Heatwave. And if you're familiar with Redshift, it has kind of like two modes, two configurations. There's like a memory optimized and storage optimized. The memory optimized is like faster, and that's more expensive. And so the MySQL Heatwave is kind of a geared, we wanted to compare, again, kind of apples to apples. So we chose that one. Of course, if we choose the storage optimized, and the Redshift won't be competitive. It will be like completely, behind the Heatwave. So we chose like the best one, and this is what we get as a result. So the Redshift memory optimized versus a Heatwave. Heatwave is close to 3 times faster, on average, running those queries. And you can see what we did at the bottom. Like it's Redshift is like 4 DC to 8x large. So it's not like we take the bad ones. We take comparable hardware, and a Heatwave as well. So you can see what we did. And for 3 times faster, you get it's about 3 times less. It's like a third of the price to use a Heatwave. And since we're talking about Aurora, let's just do some comparison, because even though Aurora may not be considered much for analytic workloads, if your data is in Aurora, you may still run some reports. You may still run queries that are kind of analytics, just because it's there. And so what could you expect for Aurora versus MySQL with Heatwave? Then the difference is just like incredible. So over 1,000 times faster, and using TPCH, and still way cheaper, even when you use Heatwave. So that could be a reason. Price, performance, functionality are kind of some pretty good reasons to migrate from Aurora to Heatwave. Okay, so because the MySQL database service is a cloud service, then it plays well with other services in Oracle Cloud. So here's a good example of how you can integrate various sources of data with the MySQL database service and with Heatwave. We have a data integration service that can integrate sources that are relational databases, like for example Postgres or MySQL, or SQL Server. So all of these can be like sources to be integrated in the MySQL database service, as well as files like CSV files, JSON files, Parquet, and more. So we plug in the rest of the Oracle Cloud. You can make a really nice, let's say, architecture design that is very inclusive of various types of data and various types of databases, and use that with MySQL and with Heatwave. Okay, so let's go to the meat of the presentation, which is the migration process of going from Aurora MySQL to the MySQL database service from cloud to cloud. So first off, the Oracle Cloud has a couple of tools, has basically some tools to do migrations. So let's say there's kind of a catch-all migration tool called Golden Gate. And Golden Gate, if people have been using the Oracle database, they may be familiar with Golden Gate. It basically does replication between data replication between various types of databases to various types of databases. And that, that includes the MySQL database, and that includes the Aurora MySQL database. So that could be like one way to achieve that. Golden Gate has the ability to do the initial data transfer, and it has the ability after that to also do the replication and the synchronization. So we have this as a service. There's Oracle Golden Gate service. We also have it in the marketplace image, like in the marketplace as an image, which is kind of like the on-prem version of Golden Gate, but running on a compute node. So that could be like a pretty flexible way to, let's say if the service doesn't do everything. So if it doesn't do what you need, then the marketplace image does everything. So you can use that. But going from MySQL to MySQL, or what I call a MySQL flavor database like Aura MySQL to MySQL has some native tools to help do that. So the two tools are MySQL Shell. So this is kind of an admin tool that we created to manage clusters and to manage various things in MySQL, but also to manage migration. So you could do you can migrate data, do the initial data transfer from Aura to MySQL using that tool. And then once that's done, you can use the MySQL replication that's built into MySQL to do the remaining, or if you have, you could even have Aurora as your source going on, in the future, and have the MySQL database service as well, using replication between the two. So you can do migration, but you can also do just connectivity between the two using replication. So just before you even start, this migration process, there's some things probably to take into account. So I call them parameters of the migration to maybe determine. So first off is, how is your application going to connect to MySQL? Is it going to connect by an IP address? Is it connect with a DNS name? If it's a DNS name, is your application going to be running in OCI? Is it going to be running in on-premise and AWS? Because applications could run, they don't need necessarily to run Oracle Cloud. We prefer that, but they don't really have to. So, but you still need to think about that. And how is your failover or your switchover going to be performed? Another consideration is the version. So MySQL database service, like I said, is MySQL 8. Aura is not MySQL 8, so it's like a prior version. So there's going to be an upgrade process at the same time. Fortunately, Aura uses InnoDB, but let's say it was not Aura, maybe you're going from on-premise. Just be aware that the MySQL database service uses the InnoDB. So if you have InnoDB is like the premier storage engine for MySQL, that's just transactional and so on. So if somebody's on premise and they have MySAM, then there's going to be a migration, to InnoDB. So part of the migration tool, part of the MySQL shell, there's an upgrade checker that will look at your configuration settings and your database objects like columns and data types, and just tell you if there's anything to take into account, that to migrate to be part of the migration. So you have to use that. And then what is the database size to migrate? What is the data size? Is it a few gigabytes? Is it terabytes? Of course, the bigger, the longer the transfer is going to take. So that's take into account. And then are you okay to do the full migration during a downtime period, maybe during a downtime window, like a maintenance window, in which case you can make a snapshot, copy everything, and then, it's very easy. Or are you going to need to do to use replication to always synchronize until the time of the cutoff? So that's kind of something to think about as well. And of course, if it's a giant database, then maybe your window of maintenance, their maintenance window, maybe it won't be long enough. So just kind of think about these things. So I mentioned that you can do replication between on-premise databases and or other cloud like Aurora databases to MySQL database service. So that's nice. It's called a channel in on the MySQL database service side. So you create a channel to one of these to the other source that's either on-premise or in a other cloud. Works perfectly well. But you do need to have, there's like two things you need, so you need to have binary logs. The binary log, if you're not familiar with MySQL, is a kind of a transaction history log that every time you do a commit, the transaction is saved there. And so you need that because the MySQL database service through replication is going to collect those transactions and then execute them, like basically just apply them locally on the Oracle Cloud side. So you need the binary logs at the source. And you need also something called the global transaction ID, which is what we use to ensure that the transactions are synchronized on both sides. The global transaction ID is kind of like a tag that puts an identifier for each transaction, so you can always track where you're at in terms of synchronization between the two MySQL servers. So binary logs, GTID, you need both enabled. All right, so this is the kind of the data migration steps, the kind of or an overview of how it looks like. So by using the MySQL shell, the first thing is you dump from Aurora to the Oracle Cloud object storage, and then you create a compute node on Oracle Cloud, install the MySQL shell, and then import into the MySQL database service. So to download the MySQL shell, just go to to the mysql.com, go to downloads, and get the shell from there. So you're gonna need that. Okay, so to dump, there's a simple command in MySQL shell called dump instance, and basically with it you can put a filter which tables. Maybe you want to bring everything, but maybe you just want a subset. So you can filter on schema, on tables. You can even filter users specific accounts. So you can put a lot of filtering options. As well, you put the destination, the information of the Oracle Cloud object storage. And one other thing is that I mentioned earlier, if you're looking at doing like a with downtime, then maybe you can just do a snapshot. So you don't need to really consider the consistency. You just make a if there's no updates going to the to Aurora while you're doing the migration, then that's easy to migrate. You just export the data and re-import it. But if there's still writes going on to Aurora, then the MySQL has consistency options to enable. The MySQL shell has options, and then it will basically make a snapshot, and then you can use the moment of the snapshot after that to replicate the remaining transactions. Okay, so I talked about the filtering, and just one quick note, on the MySQL shell dump, just a comparison with, especially with MySQL dump. So longtime DBAs of MySQL will know MySQL dump. Probably they've been using MySQL dump as a way to migrate data or to backups. But MySQL shell has a much improved dumping capability. The dump instance is multi-threaded, and it's just like faster in every possible way and better in every possible way. So this is just a kind of a comparison of the performance. So it's kind of, it's kind of a close to 100 times faster when you use that compared to the MySQL dump. So this is helpful for the migration. Please, if somebody's doing the migration, use MySQL shell dump instead of MySQL dump. If you're going to be doing it on your own, look at MySQL shell. It's going to cut your migration time quite dramatically. And then once the data is dumped and when it is in the Oracle Cloud, then we do the reverse. Okay, we import from the dump into the MySQL database service. And here again, you can do filtering, because you could do technically a full dump of your Aurora into object storage, and then you could say, okay, I'm going to make two MySQL database services, one for this schema and one for that schema. So you could import, you could put a filter on each and just get part of part of the database, if that's what you want to do. So you can absolutely do that with the function called load dump. Okay, so there are some things I just want to point out, some things to consider, just before you do your migration. With Aurora, you choose basically the shape of your writer and your readers. So just be because Aura is kind of like a premium, it's like a premium service, let's say, versus RDS, but it also has a premium pricing as well. So what I've noticed often is people will they will choose like the cheapest shape, like the R5 large. And let me tell you that when you do the export, the R5 large can be pretty slow to export. Okay, so at least for the time, if you're using one of these shapes on the screen, and I call them the up to, the up to family of Aurora shapes, those ones can be pretty slow to do the export. I recommend, if you're using those just on a daily basis, at least for the time of the migration, please do upgrade to like the superior shape, just because it's going to cut down your migration time by a significant amount, by a huge factor. Um, when you have like the kind of like the guaranteed SLAs, for like the guaranteed bandwidth and stuff, makes a huge difference. So if you're on the R5 large, please consider, take the hit, take the cost hit and migrate and upgrade for the time of the migration. Hopefully, maybe it's the last time you pay for that. So just do that, and then you'll be good. So the migration will be much faster. Some other considerations is okay. So Aura has 5.6 and 5.7. 5.6 is pretty old. It's like 8 or 9 years old now. I think it's 8 years old, and so it's been a lot of things happening since then in MySQL, and so it's missing some functionality. And because of that, when we do the migration from 5.6, we don't migrate the user accounts. And also, if you need to do if the Aura is continuing to receive updates, there may be some limitations on the consistency in terms of the DDL changes, because we have to use like lock tables, so that locks the tables. They cannot change, but it doesn't prevent creating other tables and dropping tables. So there's some limitations in Aura 5.6 based on being MySQL 5.6. Okay, so that's something. And I mentioned earlier, GTID and binary logs are required. And I believe that Aura 5.6 doesn't have GTID, for example. I don't think it's an option. I'm pretty sure it's not an option. So, just be aware that there are some limitations there, with 5.6, Aura 5.6. So one way to get around that is you can make a replica of Aura 5.6 in AWS. It could be a replica using MySQL Community Edition 5.6 or MySQL 8. If it's 8, it's been better, but you could use like 5.7, or you can use AWS native abilities to do backups and restores. So you could make an Aura 5.7 read replica of your 5.6, and then we can do the migration on the 5.7, and we can do the migration while it is a replica. Like you can create a replication link between the two, and we'll just do a migration starting from your 5.7, and then there's fewer limitations. It's going to be a little easier. There's also one thing I do want to mention, that like a really important point, is the last line on this slide. So the way that RDS is implemented, and consequently Aurora is implemented, is that Amazon made some let's say AWS specific tables in the MySQL database, and the MySQL database in the MySQL database service doesn't work with that. Okay, so when you do your export using MySQL shell, you have to put a filter and filter out the MySQL database, and then your import is going to work. Okay, that you have to do that. So these are some things to be aware of and to consider in the migration process when migrating from Aura to MySQL database service. And these are kind of the steps, just kind of more in detail steps. So to migrate to the object store. So the best way is really to migrate from the MySQL, from the Aura directly to the MySQL to the Oracle object storage. So to do that, you go to Oracle Cloud, create a bucket in object storage. It could be public, it could be private, but maybe it should be private. Private is better, at least it's hidden from from the public at large, unaccessible. So make it private, and then go to your user settings. And from there, you can get what we call a configuration file, which has your tenancy information, and then you can create an API authentication key that is going to be used for the time of the migration. So then when you start, when you type the command for to dump, then the dump command is going to have you put the configuration file, the API information, and also your bucket name, and then it will just dump to that bucket. So that's pretty easy to do. And then the reverse is true as well. Okay, so you use this information when you import, when you use the load dump function. Okay, so it's the same information, just copy the config file and the API key, and you can import using that. And by the way, when we copy from Aura, or like from Aura, from Amazon to Oracle Cloud, there's some the data itself will be encrypted. Okay, so you don't have to worry about that. We use an encrypted channel to do that. In fact, here's how we can connect AWS and Oracle Cloud, and make aside from the fact that we encrypt using TLS, we encrypt using between the two endpoints. You can, on top of that, you can link the two clouds and make secure connections in addition to the existing secure connection. Okay, and the way we have basically two mechanisms that can do that. So one is you can create a VPN connection between AWS and Oracle Cloud, and so both clouds have this ability. Okay, so it's very simple to do. You can even search on YouTube on how to do that. There's tutorials by the Oracle Cloud networking team. They've made tutorials on how to make VPN connections between the two clouds. But you can also use something called Fast Connect in Oracle Cloud and Direct Connect in AWS. And so these are, we do that using, it's basically like a shared partners that we have that have physical links between the two clouds. And so this is very useful because you could do that for the migration, but you can also, let's say that you do a partial migration. Okay, you say, okay, I want all my Oracle databases, like Autonomous Database, Oracle Data Warehouse, all these things. I want them by the Oracle experts in the Oracle Cloud, and I want the MySQL by the MySQL experts in the Oracle Cloud. And maybe for whatever reason, you keep your applications either in AWS or you keep in let's say on-premise. So when you use the Fast Connect, what happens is that the subnet of Oracle Cloud looks just like if it was a subnet of AWS. Okay, so you can run applications on one cloud and a database in the other cloud. Okay, you can kind of mix the two clouds together, and this is using Fast Connect and Direct Connect in AWS. There's something that's really cool, by the way, but in terms of pricing in the Oracle Cloud, is that whereas in AWS you get 1 gigabytes of data transfer for free out of AWS per month, in Oracle Cloud you get 10 terabytes, 10 terabytes for free. And then after that, it's and then the incremental after that in the Oracle Cloud is very cheap. You'll be very surprised. So there are people who say, hey, it actually makes financial sense, even if it's two different clouds. Even if there's maybe if there's like a networking cost between the two clouds, you know, the difference is so big in terms of pricing of Aurora versus MySQL database service, and also considering the 10 terabytes free egress from Oracle Cloud, it makes a lot of sense for other people to say, you know, to combine the two clouds like that. We have a blog. You know, there's a number of blog articles that mention how to do that, how to create a fast connect / direct connect between the clouds, how to do VPN connections between the clouds. So just do a search. If you search for let's say using applications in AWS that use you know, the MySQL database service in Oracle Cloud, you can search for that and you'll get a blog post that talks exactly about how to do that with the exact steps with screenshots on how to do that. Okay, so I think I already kind of mentioned the import. The import is kind of the same reverse steps, you know, from the export. Just for your own, you know, performance value, you know, for your best value, it's better if the shape that you use to run MySQL shell to do the import should match the shape of your MySQL database service. You know, having like saying, okay, I'm going to put like a 64 CPU shape, and you have a smaller MySQL shape, then you know it won't make full use of the 64 CPUs, or at least won't make the efficiently. Okay, so just for your own knowledge, you don't make it smaller because then it's going to be slow. But if you make it about, you know, the same, then you get a really good value for the import. So by the way, one of the, you know, the MySQL database service can have up to 64 CPUs, which means 128 you know, threads, concurrent threads. So you know, there's many ways to get high performance. You know, yeah, there's a Heatwave, gives very fast queries, but if you have also you know, like you know, thousands of queries per second coming to MySQL, then the good news is you can scale the number of CPUs. So you could have 64 CPUs, a terabyte of RAM, and you get like, you know, very high performance using that. Yeah. And okay, so once your data migration is done, how to do replication. So like I said, you need to make sure that bin logs are turned on from on your source, you know, on your Aurora. Make sure that GTID is enabled. And then the way to do the cutoff is that first you cut off the connection between the applications and Aurora, just to stop the flow of updates, you know. So stop the flow of updates. Let the replication just finish picking up the updates, which hopefully should be you know, pretty quick, especially if you use Fast Connect. Just to often the Fast Connect, what we kind of noticed, what I've noticed, is that cloud providers like Amazon, Oracle Cloud, you know, Azure, often for some reason we tend to be in the same cities, and so when you use Fast Connect between between the clouds, it's pretty typical to get like under like 2 milliseconds of lag, you know, not lag, but of latency. So they're probably not going to be much, you know, the synchronization between the two is almost instantaneous, but not quite instantaneous. So you just have to wait for the MySQL database service to pick up all the changes from Aura, and then wait for them to be applied, and then you switch your application over to connect to the MySQL database service. So in this case, the only kind of interruption of service to plan for is going to be that amount of time, you know, just switching from one cloud to the other cloud, the connection. Hey, but there's another way to do all that I've talked about. You know, I could have saved us a good 30 minutes with this one slide. So there's another way to do migrations, is that Oracle has what we call the Oracle Cloud Lift service. And what it is that you can ask your Oracle Cloud representative to get somebody from Oracle Cloud Engineering to, you know, to help you do the migration. Okay, so we know how to do that. The Oracle Cloud Solutions engineers know how to do the migration from Aurora to MySQL. We have the experience. So what I said is right on, is, you know, how to do it. And but you can also ask your representative to get some to get like Oracle to do it, to help to do it. So I think if somebody is watching right now, they're probably interested in the MySQL database service. Good news is it is available as in a kind of a free trial for 30 days. It's just part of like the Oracle Cloud free trial, 30 days, $300 of credits, and of course, if you look at the pricing for MySQL database service, then you know that $300 is going to be plenty, more than a month worth. So go to oracle.com/cloud/free, sign up for the free trial, and create a MySQL database service. And if you need any help, just contact any Oracle person, and they'll reach out to to the MySQL folks at Oracle. And if you want, follow our news, the MySQL database service news, the MySQL 8 news, MySQL enterprise news, all of the MySQL news, mysql.com is the place. We also blog at blogs.oracle.com/MySQL, and we have Twitter, Facebook, and LinkedIn as well that people can subscribe to. And one final thing. Okay, so I talked about the Heatwave. It's dramatically faster than basically any MySQL thing that exists. So if somebody is interested in trying it and looking at whether your slow queries are going to be improved by using MySQL Heatwave, and if it's worth doing the migration to a MySQL Heatwave, then the MySQL experts like myself and others, my colleagues, are available to help determine that, help do the migration and the testing and seeing if it's going to give you the value. And so again, you can sign up for what we call a health check. So you can sign up for the free health check, mysql.com/health check, and somebody from our team, might be myself, somebody else, will get in touch and talk with you about how we can proceed with that. So I hope that people do that, and I hope to speak with you once you do that. And if there's any questions, just sign up for the health check, and we'll be happy to to get in touch and create the contact. Thank you very much for attending this session, and hope to talk to you soon.